Welcome back. This time I should be a little bit more free. I kind of had to go in the middle of that last one. So we're looking at a screen here. By the way, my name's Ted. We're making games on the Mac from scratch using Metal as the renderer. And on this day, we've actually arrived at a point where we've got triangles being drawn on the screen, and they're actually drawn in the coordinate system that maps to the game itself. So we're no longer in normalized device coordinates. We're no longer in minus. So on this far side on the x-axis, -1 to 1, and then 0 being the middle, and -1 to 1 on the y-axis. We're actually in coordinates that map to pixels on the screen. So that's actually going to be really useful for making a game, because then we can start talking about things having a, say, like a pixel space position. We can talk about something being at pixel, I don't know, 1.5 or something, or pixel, pick any point, right? We can define something as residing at that point. So it's going to be a lot easier to talk in terms of game logic. So we've got a triangle, right? So that's the start. We actually want to start kind of beefing this up a little bit and move it more into something like a rectangle. So if what we could get, it would be nice if by the end of this we could just get something like a rectangle that is moving on the screen every frame, and that, yeah, like a single solid colored rectangle that moves across the screen, or maybe like cycles across the screen or something. That is the start of a lot of things, because it means we can draw multiple rectangles on the screen in multiple positions. So there's just a lot of stuff that's going to be really useful for having that. So let's dive into it. Look at our code here. We got started, right? So we got started with 1/2 triangle here, or we got with 1/2 the quad. And I believe we did this triangle right here. So this one, and then this one here. So what we need to do now is the other triangle. We need to do this top triangle. So that means we need this vertex right here, which I think is just, because remember we wanted to put this in the middle of the screen. So the x minimum is 486, right? So this is actually the minimum triangle. So we're just going to copy that one, and we're going to move that. We're just going to call this, I don't know, vertex 4, right? And it's going to be the exact same vertex. Don't worry too much about the fact that we're like copying our data here and it's basically the same. The idea with a lot of this is just to get it up and running and then figure out later how we're going to make it better. So yeah, there's probably a more optimal way to have this thing draw a quad, but we'll get to that later once we start running into performance issues. And truly, if you look at it, if you actually like profile the GPU, it will draw this entire thing in like microseconds. So you'll easily be able to hit 60 frames a second, which is considered normal. So this really isn't a bottleneck right now, and it's really not like much of a concern. So we'll just draw this as like a triangle list and figure out how to optimize it later. Is going to be a much better approach, because by that time you have more of a cost justification for doing the optimization. So you want to kind of wait. So now we have one more vertex. What we want to do is probably this one, like max. Actually, maybe we'll do min max here. So which one? So we don't have this one. We want the x minimum. So we got that, and then the y maximum, which is 524 on the y. Yeah. And then just that final vertex. That's just max. So both maximum. And we'll just build this. Da-da-da. It's building. Wow, it takes a while. I'm not entirely sure why that is this time. A lot of times what I notice is like my first compiles take quite a bit of time on this Mac. This also isn't a very fast computer. It's kind of a slower one. Gosh, that is taking much longer than I would like. Okay, my computer is spinning up its fans. This does not sound good. Oh, come on, this should be short. Seriously. Okay, so we got something. Hang on. And it built. Wow, that was incredibly slow. That sucks. Okay, so let's try and launch this again. Oh. Interesting. So that did not do what we wanted it to do. Why did that not do what we wanted it to do? We're here. Is there a reason? Oh, I know why. It didn't do what we wanted it to do because we literally did not tell it to draw 6 vertices. Hopefully this will build much faster this time. And it's not going to take like all of our... Okay, yeah, so sometimes, I don't know what happens, but sometimes like the Mac gets stuck on some process or whatever. So, okay, now, all right, so you can see that we've got what looks like a square in the middle of the, inside the middle of the screen. So that's like the start of something, right? There's a lot that you can do if you can draw a square on a screen, right? So now what we want to be able to do is, let's say we want to take this square, and we want to draw multiple of them basically in any position on the screen, right? So what would we do to do that? And now this is going to be very different from a lot of computer science type, a lot of traditional education. I don't love the way that a lot of education starts to talk about these things, because what they'll have you do is they'll have you try and write the function first, as if you can predict what all of the inputs are, and as if you can magically like come up with the way, as if human beings are really, really good at just abstract thinking this way. That's what I would call like the top-down approach. So a lot of education is usually like, okay, so what we're going to do is we're going to go, and so we need a function, right? So we'd go all the way up here because we definitely need a function. So we would do something like, I don't know, void, like draw a rectangle. And we would think really hard about, oh gosh, like what are the parameters that go into this thing, and how are we gonna draw the rectangle? And we think, okay, well, maybe it needs like X center position, right? And then like Y center position or something. And then it needs something that's like, okay, what about the width? And then the height, and then if we just stub out all of our functions this way, and sort of like plan in advance what all of these are going to be, then we will somehow arrive at a good way of designing the software. We'll just write all these functions out. We'll just model and draw all these diagrams, and if we do that, then the software will just pop into place. And this is the one area where I 100% agree with Casey the most. This is where we are probably the most aligned, is that idea of doing software is just like, it's just straight up wrong. This idea that we can pretend in advance how the thing is going to end up working, it never works out that way. I've never been successful at doing that. And what I found is that a lot of my colleagues who are usually quite smart, what I find is that this style of thinking sort of stupefies them. It makes them unable to, it kind of gives them like a, I would call it like a blank page syndrome, where, you know, you're like a writer and you're just like sitting in front of the computer and you're like, oh gosh, like what do I write? Well, I think I want it to be a story about, you know, a wizard, or maybe it's about this or that. And that's just trash. Like what you'll end up doing is you'll end up sitting there and coming up with, you know, vague theories of how your thing should theoretically work without actually building up sort of a real knowledge base from the bottom. So we're not going to do any of this kind of like abstract sort of function design, or like abstractly trying to define how a program is going to work before we work on it. What we're going to do is we're going to take things that we've already made and we're going to elevate them up into a higher status. And in that process, the structure that is natural to the problem domain that we are solving will reveal itself. So what do I mean by that? That sounds kind of like woo-woo. That sounds sort of like magical thinking, but just kind of like follow me here with what we're going to do. Instead of doing this and like writing the function first, we're going to not do that. And we're going to go to the code that we already have down here, right? And we're going to use this. And why are we going to use this? Well, we're going to use this because this works. We already have this. We can use this to make something new, right? We can use this to pull out the existing concepts, because there's actually a lot of concepts that are in this code that we've already written. There's a lot of places where it's already pretty duplicated, and we can just use that instead. So let's try that out. So a lot of times what I do when I'm trying to come up with like a general function for how something should work in a program that I'm writing, I just take code that I have and I copy it, right? So I'm selecting it and I'm hitting yank on Vim. And I'm going to go back up here, right? This is where we want it to be we wanted to have the function, right? And now I've got something to work with. I've got like a template that I can use to build this function up. And I already know what it's going to work with because I'm already using it. So I would do something like, I would call it draw rectangle just as usual. And now there's a few things that we kind of already notice, right? So, so one thing, right, is we have this idea of an array, right? An array of vertices, right? So we're certainly going to be populating an array of vertices. So let's formalize that, right? So in the C programming language, what you would do is you would just you would make a pointer to it. So you do game vertex star vertices. And that's one parameter that we are certainly going to need in this function, right? Now there are other parameters we're definitely going to need. So that's one of them, right? And now this kind of makes sense, right? So we are not going to return anything. We're just going to fill this. We're just going to fill in this thing. So this assumes vertices is a 6 vertex buffer of some sort, right? So what we need to do is we probably before we call this function, we need to just pass in a pointer to a buffer that has at least 6. Now you could do a bunch of other things at runtime. You could bound check. You could bounds check this thing. There's a bunch of stuff that you could do, but for the most part, you know, just to get something up and running right now, we probably don't need to do that. Because yeah, what you could do is you could say, okay, if we ever write past, you could have like an assertion at the beginning that's like, you know, assert, assert that the size of this thing is a certain amount, so it's not going to just crash if you get past, the third vertex or something. But we don't really need to do that for this right now because we're just trying to get something up and running. So, all right. So we know we're going to need this because that's already in the parameter, because that's already something that we're working with, right? Now, what else are we going to need? Well, this, we're almost certainly going to need these, right? So this is something like, this is the color, right? So we need that color. So we have some concept of like a color, right? And, well, what is that? We could say that's, actually, let's go back to our definition of game vertex. Yeah, vector float for RGBA, right? So one thing we could do is we could pass in vector float for RGBA, right? Now that is going to be our color, right? So instead of doing this here, we can just have, I don't want to call it RGB, we'll just call it color, right? And so this function assumes that we're just going to take a color and we're going to pass it in here as this parameter. And then we can get rid of all of this and we can just go color, right? Now at this point, and this is why, this is one of the reasons. Okay, so another reason that I do not love this, and I think that object-oriented programming is largely to blame for this particular pedagogical style. Another reason I don't love the whole, like, just design all your objects and systems together, before you actually get a thing working, is because, well, what are you going to do? Like, go for days and days and days and then, like, not actually test your thing? Right now with this, what we have, even though it's not quite what we want it to be yet, we have something that we could actually test to see that it's that it does mostly what we want it to do. So how could we test it? Well, let's just take this right here and let's copy it. And let's go back down over to this, right? And now instead of doing this part, right? Instead of actually calling this, we're just gonna call our draw rectangle function, right? And then what we're gonna do is we're going to first of all we need to just create a little, like, allocate this thing like on the stack. That's fine. We can figure out where it lives in memory later on. But the vertices here, we can figure out where that lives in memory later on. And so we'll just for now we'll just allocate like 6 of these, right? And we don't necessarily care much about that, so we'll just pass that in. So these live on the program stack. Basically, with any program, there's like a stack of variables that just occupy memory on the program stack, and every time you exit a function, the stack, like, they come off the stack. So that's basically what's going on here. You obviously don't want to fill up the stack with too much stuff, because if you do, then you'll hit the max of like what can be done on the stack. So if you have really long-lived stuff, or you have something that's like much bigger than what the stack can handle, you actually need to like do your own memory allocation for it. But this is fine because we're only really going to draw 6. We're just going to draw like one quad here. So, all right, that's great. So what about a color? Well, we already have that. That's just this. So we should be able to just pass that right into this function, right? And that's blue, right? Looks like that's probably not going to work. All right, so what we can do instead is we can do game color, or we can do vector float for color. We'll just call it blue. And that's this. So you can see what we're doing is we're actually just pulling these concepts from the bottom up. We're just, we're inventing these concepts kind of using our own, using code that we've already written. So now this should do, if all is correct in the world and we don't run into any compile errors, this ought to do exactly what we had previously, right? It ought to draw a blue rectangle in the middle of the screen. So let's try that. Ugh. Redefinition of vertex. Okay, so that's probably, oh. Actually, that's fine. Well, that's not fine. We can actually, so I'll get into this later, but basically what we want to do is we want to separate. This is actually going to use the vertices from, this is probably okay. See how we're actually getting it from our vertex buffers. So this is just going to draw straight into the actual vertex buffer. Now that I think is okay just for testing this out really quickly, but later on we're not going to want that because we actually need to keep track of how many vertices are drawn and how much we want to draw on that frame. So I also just think it would be a good idea to separate the memory that's being used for the quad that we're going to like push into the vertex buffer versus just writing straight into it. So there's going to be a better way of doing it than this, but for now, I think this is totally okay just to check how we're doing it. So that should build. Okay, so that built. Now we should just run it and see what we get here. So I'm just going to run it, and voila, right? Now, this gets kind of cool because it makes it so that we can really easily change stuff, right? So what if instead of blue, we want to use red? Well, that's really easy because now I can just do this. And instead, red is 1, right? RGB. And so instead of passing blue, I can just pass red. And I can compile it. So functions give you this amazing kind of flexibility. Obviously, functions are really cool. Obviously, abstraction is really cool. It's really cool that you can do something like this from the bottom up, and you can create this like this red square. But the problem, I think where people run into issues with abstraction is when they try to build the system from the top down. And they don't test it along the way. And then there like comes a point where they should have validated or tested one of their assumptions, but they didn't do that. Instead, they tried to kind of create this like grand system, right? Before actually testing the little parts of it. And when they're too late, they kind of like end up creating a noose that they hang themselves with, essentially. And then by then, it's just like such a mess that it's very difficult to reason about, difficult to fix. So what we're doing is a more gradual thing. We're kind of slowly pulling the abstractions out of the system as it really is, not as it theoretically could be, right? So now that we have this, I'm gonna bring back the blue. So I think what we want to do is we want to, instead of copying straight into the actual vertex buffer that metal is going to render, which is this thing. So metal is going to render these, right? What we want to do is we want to just have like a separate thing for our quad, right? So we can pass the quad vertices in, right? And then we can draw this rectangle. And now, what would that do? Well, what we want to do is we want to be able to call this multiple times and draw multiple rectangles in multiple places. So actually, let's not do that yet. Let's do that later. For now, this is fine. The next thing we want to do, because we won't be able to test that yet, the next thing we want to do, and we can get rid of this code too. We can also get rid of this code here because we don't need it, because we've already proven, or we've already used that, taken the information from it that we were going to get. And notice another thing is, like, in the process of doing this, I have given zero thought to where this draw rectangle is going to live, like it's what file it's going to be in. Like I give zero cares about that, because that is something we will figure out later. Right now, what we're trying to do is figure out what the structure of this function looks like. And if we can get this working, and if we can get this to where it's drawing rectangles multiple places on the screen, that's like a huge win, right? So like, let's get there first, and then we can start thinking about, oh, how do we organize our code? What files? Like, that's a second order problem. So now that we're here, what other patterns do you notice in this, right? I'm noticing a few things. And one thing I'm noticing is there's some concept of, there's some notion of like a minimum x and a minimum y, right? And a maximum x, or minimum y, and a maximum x and a maximum y. Do you notice that? Because what we've got here, they happen to be the same, right? So they happen to, those things actually are the same. So here we've got, 46, 46. 46 is the minimum on the x, and it's also the minimum on the y, right? But the maximum on the x is 524, and the maximum on the y is 524. So now, what if we just did this, where now we definitely still need this information, the 524 and the 46, that's really important, but let's just start filling this in with our existing numbers that we know. So we know 46 is min x, right? And we know that 46 is min y, so that's this vertex, right? And this is also, 46 is also min y over here, right? Now 524 is actually max x, right? Oops, don't want that. 524 is max x here, and then this is going to be max y. Fill that in. Okay. And that's going to be min y, min x, because this is basically the same one here. Min x, min y, so we'll just copy that. You're going to have repeats of vertices. So that's min x, and then this is maximum y. Okay. And then this is max x, max y. So same vertex here. Right. Cool. So now we can call this same function and we can start passing in, right, like a lot of different places where stuff lives. So all that I do now, because the function has changed, I select this code and I copy it with yank, and I go back down to where it's used. So right here. So this is no longer right. This is the new name of the game. Color is blue. Okay, minimum x. Well, we know that is 486, right? Okay. Minimum y is the same. okay, maximum x is 524, right? Maximum y is 524. This, you will agree, should do exactly the same thing as what our previous bit of code did. So let's compile it and find out. Okay. So notice how what we're doing is this whole time we're just testing and testing and testing. A lot of people talk about test-driven development, like you're going to write automated tests while you're programming, but I think that's actually a pretty crappy approach too. What you should be doing is constantly, iteratively testing small things as you go along and validating your assumptions as you build up these systems from the ground up. I think that's a much more effective way of going about programming. I think you're going to get way better results if you do that. So now we have this kind of idea. What's so cool about this is, well, we could move this pretty much anywhere now. So what if I wanted to do something like, now x starts at 0 and y starts at 0, and this goes to like 128, right? 128, just to play around. Well, now we've just drawn a totally different rectangle of a totally different size somewhere else on the screen. So that I think is pretty cool. And if we just like run our little app here, we'll see that. Yeah, so now that's in the bottom corner, right? So that's really cool. We can very easily tell the system where to draw rectangles and fairly quickly. So that's kind of a start, right? So now I think we start to get into some other territory, because we've got the beginnings of something that we can use, but it's not good in a few respects, right? So it's not good in the respect that we can't draw more than one yet. So we want to be able to draw more than one, yeah. And we probably want to be able to, we might want to be able to specify like some center point around which this rectangle lives. So we might want to take what we've got here and start defining it as a rectangle that has a center point, and then we kind of calculate the min and the max around that center point. So you can imagine that we represent it. Actually, I'll just on this code here on the screen, like, so that's the center point, right? So if we instead started here at the center point, actually I'll blow that up just so you can look at it. So if instead what we did is we just started at the center point here, and then we worked our way back to this position, and then we also worked our way over here to this vertex, and worked our way to this vertex, and also worked our way to this vertex, right? If we started at the center point and then kind of like worked our way there, because mathematically you can represent this rectangle a lot of different ways. You could represent it as a central point with a width and a height, or you could represent it that way that we have right here with just all the vertices, right? So ultimately, I think the real mathematical definition of this rectangle is defined by the 4 vertices, but there are other kinds of more simplified, more easier for humans to reason about kind of ways of talking about the rectangle, and one of them is a center point with a width and a height. So we'll probably want to do that just because it's going to be a lot easier to talk about it for the purposes of making a game, right? So first things first, let's figure out how we can draw multiple of these. So what we have, we need to change the style of this thing, because what we need to do now, instead of just, there's a lot of different approaches. I mean, we could just append to this vertex buffer. That's one thing we could do. But but I think what we're going to want to do, we want to change how this draw rectangle function works. What we want to do is we want to have it so it appends at the end of the at the end of this vertex buffer right here. So it just keeps appending. And we also want it to keep track of how many vertices it drew, so that we can just kind of call draw rectangle as many times as we want, and it just automatically figures out how many vertices to draw. Because right now what we've got is something that's pretty much hard coded here. So you can see I've got vertex count 6. Okay, well that's going to change, obviously. Obviously, in a real game, you're going to have like thousands of these. You know, you're going to have quite a few vertices. And so, you know, you don't want to like manually track that every time you compile your game. That's just going to like make your life a living hell. So instead, what you want to do is actually like have a variable that that tracks that. So again, we're not writing this top down. What we're actually doing is we're pulling it up. So what we have here is this number here. And now what happens is this vertex count becomes a variable, right? And now where does that live? Well, it lives up here, let's say. Okay, and then somewhere after this function gets called, vertex count goes up by 6, right? It needs to go up by 6, right? Why 6? Well, it needs to go up by 6 because that's the number of vertices that are inside of a quad, right? So there are 6 vertices in a quad. We could even, if we wanted to, you know, just define that so that, you know, that's hard coded. So we could do something like this. We could say pound define quad vertex count 6, right? And we could just use that every time. So that's certainly something. Every time we draw a rectangle, the number of vertices is going to go up by 6. And then that increase, where that vertex count is, in the next triangle draw, or in the next quad draw, is then going to, you know, that's going to be the starting point for the next one. So, all right, that means that the way that we change this has got to change in some pretty important ways if we want to draw multiple of these. First of all, we're going to just call this so first thing we need to have a separate buffer that's just for the quad vertices. Actually, we'll pass the vertex buffer in, but we also need to pass in the vertex count, right? Because if we don't pass in the vertex count, then we can't track where to start the next time. And what we'll have is and we need to pass a pointer to that because we don't want to just copy it in. So what we'll do is we'll increment the vertex count every time we draw a triangle, and we'll pass in the vertices. So or every time we draw, sorry, not a triangle but a quad. So that means that the nature of this function changes. U32 vertex count. Okay. Now what we're doing is we're just increasing the number. We're going to pass this in, and we're just going to keep increasing the vertex count every single time we write another vertex in, right? And actually, we don't really need to have. We don't need to increment it by 6. So this works just fine. So see how we're just increasing that every time? So on the first one, what this will do, this plus plus, is let's say on the first time it's 0. So we actually don't even need this now that I'm thinking about it. the first time it's 0, then it's going to use 0 as the index, and then it's going to increment by 1 afterwards. And so that's kind of what we're going to do. And it's just going to do that for each new vertex, right? So it's going to use the existing count, and then it's going to increase it. So that totally works, right? And now we can go back to where we called this, draw rectangle, right? And we're passing the vertex count. We don't even need this, really. Okay. So now this ought to draw those same, this ought to be exactly the same thing, except now the only difference is we should be able to call this basically as many times as there are vertices in our vertex buffer. Now I say that because, remember, this vertex buffer is probably thousands and thousands of vertices, right? It's we can actually put a breakpoint in the debugger and see how big this thing actually is, right? So it's whatever the memory page size is times 1,000. Now, if you draw too many rectangles, right, you just draw so many rectangles that you end up coming off the end of that buffer. A lot of different, I think this probably would crash if you did that. So you kind of have to know that the amount of stuff you're drawing is not going to be, is never actually going to be greater than the amount of memory that you have allocated in order to do that. But aside from that one constraint, you could just keep drawing more and more rectangles. So let's build this. You'll just see. All right, so something's wrong. Oh, that's right. The vertex count is, yeah, we're not actually passing we're not passing an unsigned 32-bit integer. What we're doing is we're passing a pointer to 1. So we're passing u32 star, right? Because we're passing the address of the variable, we're not copying it. So what we need to do is this star vertex count, right? So that would be the same. Yeah. This will probably complain about some other stuff. Maybe not. Okay, genome rectangle. Oh, I think I got the order of parameters wrong. Okay, that's fine. So all that is we put blue after this, right? So we got that. So if I get the order of parameters correct, then we should be fine. Nope. What did I do wrong this time? Oh. Wow, I do the same thing. Stupid. So I just forgot a okay, I think I've watched too much Handmade Hero. I have like exactly the same expressions as Casey at times. Oh, that crashed. Okay, interesting. Why did that crash? What was so let's investigate the crash. Float vector 4 unsigned int star. So we don't know why, but let's find out. Let's actually look. So we're just going to open the project, right? And then we're going to figure out what the deal is. We're going to run it, and we're going to figure out where it's crashing in the debugger. Assuming, of course, that Xcode wants to like play nice with us today and isn't going to totally like take forever to launch. All right. Come on. I know you can do it. This was written in an object-oriented fashion. So much thought was put into those objects. All right. Build succeeded. Where do we crash? I'm probably about to learn something. So that is, okay, where do we crash? We crashed. Auto release pull push. You got to give me more. Draw an MTK view. Yeah, but where? Oh, did I just? Draw a rectangle. Okay, I actually don't want to be in assembly right now. I would much prefer to be in... Why did I get into the assembly code here? No, that's not what I wanted. Yes, but where did we crash? All right, I'm just going to put a breakpoint here. See what's up. Oh, that crashes before it. Why would that crash before it? Okay, that crashes before we ever get there. U32 vertex count. I don't have a stream to help me out. Do we hit our breakpoint before? No, we don't. What is going on here? Okay, this is surprising. I make it seem so easy, but actually it's not. So we have that. Draw the vertex count. Oh, well, wait. No. That should start at the same place every time. Do we get here? This is surprising. It's surprising to me. I mean, just not. Is there something? Okay, I think my debugger is wrong because if I can't get a breakpoint, yeah, I can't even get a breakpoint at the start of the application, so that sucks. I'm gonna quit Xcode and restart it. That sucks. All right, let's try this again. Maybe this time I can get something that hits my breakpoint. Nope. This is what I do not like about Xcode, and when you do custom anything, it does not. So what I need to do is figure out how to get this actually debugging. So right now the debugger won't attach, which sucks. So if I can get the debugger to attach, then maybe I can actually get this to It's just very surprising to me that this will, we can't even seem to hit a breakpoint, which is going to make it really difficult to debug. I swear, Xcode is just can be such trash. I don't have this problem on Visual Studio. Seriously. How do we make this better? Come on, hit my breakpoints. Don't just crash, hit my breakpoint. It's at the start of the application. Oh, for God's sakes. All right. This is not useful. Can't get breakpoints. That makes it hard to figure out what's going on here. Can't really hit these. Seems like what we're doing is okay, but I don't know. All right. I don't want to take. Well, the only thing I can think of doing now is like, if we don't call it, what happens? Can we at least figure out that the problem is inside of our thing? Is it inside of our function? Undeclared identifier vertex count. We need that. Fine. Okay. What happens now? It said that that's where it crashed. Oh, now I actually get some debug, so that's useful. Okay, we're here. Okay. I mean, the thing is, in principle, it seems like all the, okay, so that's, all right, now what if we bring back the call to our function, recompile. Okay. What do we get? Okay. Why is that? First of all, what is the vertex count? 1. It's probably something I'm getting wrong here. I'm not really sure I understand why that's a bad access. Vertex count is 0, so this would be just drawing the very first one. And I could get this first one is just fine, right? But then why would incrementing it and then setting it to the next one not be fine? I'm not sure what's going on here. Definitely a bad access, but I don't see why it would do that. We have the vertices, right? There are certainly enough of them. So that surprises me that this would somehow be wrong. So we could do that, but then what do we run off the edge of the that seems that would really surprise me if we ran off the edge of the vertex buffer. So if let's get some more context here. What's the first frame vertices? How many are there? I thought there were supposed to be like 6 of them, or definitely more than that. We certainly allocated enough. And we certainly were able to previously get that working. Not really sure why this would give us. Maybe there's something about. I'm not sure I understand. So that's fine. There's probably some other things we can do here. We could do something like this. We could go. I don't know if this would actually help. But it would be that it would resolve to the same number, which is surprising. So something is, I don't know, star vertex count plus plus. Not really sure why that's a problem. Okay, so if we do this, add 6, at the end of it, what do we get? Okay, that works. Something about using the pointer to the vertex is not cool. We could do that. Okay, well, I'm not really sure why. Kind of doesn't matter. So for our purposes, because we're just prototyping games, and so now, you know, what we ought to be able to do is then call this again, right? And maybe what we can do is I'll just show you with like a red one. And maybe this starts at 128, and goes to like 256. And it's red. I just want to show you that we can basically like just copy this almost as many times as we want. Obviously, nothing is infinite inside of a computer. Eventually, it does run out of memory, and so there are obviously engineering constraints. But you could, you know, more or less like call this like 1,000 times or something if you wanted to, and you would just get more rectangles. So that's kind of what I want to show you. Okay. There you go. So what we've managed to do is actually, now if you really wanted to get super into this, you could actually start thinking about how to turn this into some kind of a grid, right? So you could take it and find some way of creating like an abstract notion of a grid, right, of a checkerboard or a grid, and you could like turn this into chess, right? And you know, maybe what you could have is like little figures or like that represent the different, you know, chess characters, or you could even start with something simpler like checkers, right? You could have like a circle that represents like a checkers thing, and then you could start to think about um, you could start to build up sort of this vocabulary of different kinds of things that you could draw. Basically, what we're doing is like I just gave you a paintbrush, right? It's a crude paintbrush. It's a paintbrush that only allows you to draw colored squares, but it's a paintbrush no less. Like that's basically what we've made. We can make as many of these squares as we want in as many ways as we want. We can make them move around if we want. So I think that's pretty cool. Let's see what time it is here. And yeah, so we've been doing this for like an hour now. I think now is kind of a good time to call it a wrap. So I will post the code for this. If you liked this, if you found it was useful, absolutely you subscribe, do the Patreon thing. Basically, I do as many of these videos as is warranted by the amount of interaction. I never know if people really like this or if it's something that I know people do like it, but I want to be kind of like actively going more in a direction that people are going to find valuable. So if you did like this and found it valuable, definitely let me know. It motivates me to make more content, especially if like you subscribe on Patreon or do anything like that. That really motivates me because then there's like a financial justification. And when my spouse like asks me like, why aren't you making any money doing this? I can be like, well, actually there's people that are paying. So I would appreciate it. But aside from that, it's a good place to end, and I will see you next time.